Hello everyone, we've got another I and J question here, and especially one of those that involves having to work out things from when a particle is moving northeasterly or in certain directions. Okay, let's have a look at this one. It's worth quite a few marks. In fact, it's worth 10 marks. A radio-controlled boat is placed on the surface of a large pond. The boat is modelled as a particle. At time t equals 0, the boat is at a fixed point O and is moving due north with a speed of 0.6 meters per second. Relative to O, the position vector of the boat at time t seconds is r meters. Okay. At time t equals 15, the velocity of the boat is 10.5 I minus 0.9 j, and the acceleration of the boat is constant. Perfect. So because the acceleration is constant, we know we're going to be dealing with SUVAT. So let's write down our SUVAT. Show that the acceleration of the boat is 0.7 I minus 0.1 j. Great, so it's a show that question. Well, what do we know? We know that initially the boat is moving due north with a speed of 0.6. So that means that we can say that the I component is 0 and the j component is 0.6 because it's moving due north. What else do we know? We know that at time t equals 15, so we can put time is equal to 15, that the velocity is 10.5 I minus 0.9 j. So 10.5 I minus 0.9 j. We don't need to know the displacement for this one. So we've got to find the acceleration. So the appropriate SUVAT here would be v equals u plus at. So we've got our velocity is 10.5 I minus 0.9 j. Our u is 0 I plus 0.6 j. The acceleration is what we're trying to find, and the time is 15. So I'm just going to subtract this, take the whole thing over one side, so 10.5 I, and then when I take this over here, I have minus 1.5 j is equal to 15a, and then I'm going to just divide now everything by 15. And when I do that, I find out that I get the required 0.7 I minus 0.1 j. And this is nice because this is a show that question. So we know that we've got the required results there. Okay, that's part A done. Now part B. It says find R in terms of t. Okay, so we want to find R in terms of t. So we've got all of our info. Well, let's just write that down. SUVAT. We're finding something in terms of t. We're finding the R, which is just the vector way of writing the displacement. We have our U is again our 0 I plus 0.6 j. We're not really worried about the v in this expression. And we know that the acceleration we've previously found is 0.7 I minus 0.1 j. So we can write down our s equals ut plus half at squared vector equivalent, which is that r is equal to ut at half at squared. So our r is equal to 0.6 j times by t plus a half times by 0.7 I minus 0.1 j times by t squared. So we've just subbed into our s equals ut at half at squared. And that actually is our answer done. It's only worth 2 marks. And we've expressed r in terms of t. Okay, perfect. Let's see what's next in part C. Now, part C, it says find the time when the boat is northeast. So because they're talking about the location being northeast, remember I've mentioned in previous questions, when they talk about northeast, so let's just draw a compass here, you're essentially saying that something is lying along the line y equals x. And if something lies along the line y equals x, it means that you equate the I and j components. And because they're basically talking about in part C, find the value of t when the boat is northeast, okay? So that means we need to find an equation that's to do with the direction component, like we just found in part B, and we're going to equate the I and j of the r, okay? So let's restate our equation that we had a moment ago. So we had that r was equal to 0.6j_t plus a half times by 0.7i minus 0.1j, oops, 0.1j t squared. And what we're saying is now that if the boat is physically actually going to be northeast, we can equate the I and j components here, okay? Well, on the left-hand side, we've got 0i, so we've only got this I coming from here because there's no I component coming from that initial velocity. So we can say that a half times by 0.7 t squared, that's our I components, is going to equal our j components. Our j components, what are our j components? That is 0.6t, and we have got minus a half times by 0.1 t squared from the for this come from the acceleration. So that's like our I components and our j components have been equated. Here's our i's, here's our j's. Okay, great. So I think from here we can get everything over one side. Add that over to the other side, gives us a half times by 0.8 t squared. That's just taking this across to this side. Gives us 0.6t. From here, we can now factorize out, take everything over one side, factorize out a t. So a half of 0.8 is 0.4 t squared minus 0.6 t is equal to 0. So t is equal to, well, let's factorize it out. So we've got 0.4 t minus 0.6 equals 0. And that means either t is equal to 0 or t is equal to 0.6 divided by 0.4 when we rearrange that. And 0.6 divided by 0.4 is t is equal to 1.5. So we find that the radio controlled boat is located northeast of O at the time t is equal to 1.5 seconds. And that's the 3 marks done there for part C. Okay, let's move on and have a look now at part D, the final part of this question. Now, in part D, it says find the value of t when the boat is moving in a northeasterly direction. And when it's moving in a northeasterly direction, that's subtly different to what we just did a moment ago, because previously we said, when is it located northeast? So we were talking about the direction component had to lie along the line y equals x. The subtle difference here in part D is they're saying, when is it moving in a northeasterly direction? So it doesn't matter where it is, but what does matter in this case is that its direction of travel is in a northeasterly direction. So this means that we need to find an expression for v and equate our i's and j's, whereas previously we found an expression for our displacement r and we equated our i's and j's. Okay, so let's do that then. Let's write down our SUVAT. So we need to find an expression for the velocity at this time so we can equate the i's and j's of the velocity. Right, so we know that our initial velocity is 0i at 0.6j. We're trying to find an expression for v. We know our acceleration now is 0.7i minus 0.1j. The t is what we're trying to find. We're not concerned about the displacement in this particular question now. So the appropriate SUVAT here is going to be v equals u plus at. And we can sub in everything that we need. So v is equal to 0i plus 0.6j plus a, which is 0.7i minus 0.1j, oops, 1j. That's all times by t. So let's equate the I components and the j components. Well, first of all, I'll expand it. So 0i plus 0.6j plus 0.7ti minus 0.1 jt. And then let's equate those. So we end up with our I is going to be 0.7i. So I is equal j's 0.7i is going to equal, what have we got, 0.6j, 0.6. So we deal with the i's, deal with the j's. 0.6j minus 0.1t. Okay, or that's 0.7t there. Sorry, we should have a t there. Minus 0.1t. So I can add that over the other side, this over to this side, to get 0.8t is equal to 0.6. So t is equal to 0.6 divided by 0.8. So therefore, that gives us that t is equal to 0.75 seconds. And that is our answer. So the key for this one was the equating the I and j components of the velocity rather than the displacement. And again, I know I've mentioned this previously, but I think it's super important to point out. Had the question have been asking about, so we've got north, east, south, west. So let's imagine the question said that the boat was traveling in a southwesterly direction. Then we would still have done the I is equal to the j, because whether it's northeast or whether it's southwest, it's still lying along the line y equals x. So we would equate the i's and j's. However, if the question, and it does come up these variants because they like to mix it up, let's say that they said that the boat was traveling southeast or northwest. So if they said that the boat was traveling southeast or northwest, because that lies along the line y equals minus x, what we would have done is we would have set I equal to minus j, or we could have set minus I equal to j. It makes no difference. But what we need to do is, because southeast and northwest lie along the line y equals minus x, we would follow the same approach, but we just take the I and make it equal to negative the j. But we would still equate them in the way that we had, and that's how you would approach it if they'd said northwest or southeast. But because they said northeast, it was just I equals j. But it's just good to know that if they mix it up and say southwest, that also means I equals j. I hope that you found that helpful, and I will see you in the next video.